Hi everyone, and welcome back to Talking Conservation. In the previous episode, we talked about the different types of line being used for building and for pointing. Now, in this episode, we're going to go take it a little bit further, and we're now going to go into the different coatings that are going to be used in the various different limes. So we're talking interior plaster work, which is both decorative but also to make the wall smooth, and we're talking external render, so in other words, coating to the outside of buildings and the different materials we use. So tune in, here we go. Hello and welcome to Talking Conservation,
the podcast all about conservation of old, traditional and historic buildings and sites.
with me, Rich Aylesbury.
And me, Stephen Boniface.
Internal plasters. Inside the building, the lime is still doing its job. It's just working in a slightly different way. Plasters do need to do a bit more than just look good. They're not just a decorative finish to the room. They also help to regulate the internal environment. So specifically, we're talking about humidity here. So let's cover off lime putty plaster to start with. It's soft, it's very smooth, and it's incredibly flexible. It has excellent vapor permeability. So that's moisture or water as a gas being able to pass through the tiny pores in the plaster to pass through it. So that helps regulate the humidity. It has excellent capillarity. So that is the tiny pores of liquid moisture. So if you get condensation forming on the plaster because it's got to its dew point temperature, that helps again wick through that moisture to the outside through vapor, through capillary action, essentially to allow it to evaporate. And also it's got hygroscopic behavior. So what that means is actually it attracts moisture. So humidity in the air, it actually absorbs moisture from the humidity. So again, regulates and acts as a buffer for internal humidity. So lime plaster can help absorb and release moisture within the building environment. And again, it's one of the reasons why our buildings are so healthy inside quite often, because it has this incredible ability of lime plaster to be able to do that. It's also incredibly long lasting if it's left, I say unpainted, or at least with a lime wash on it, or at least without any, with vapor open coverings. Once you start getting into the realms of putting layer upon layer upon layer of paints, and certainly oil-based paints and things, you start reducing the ability for that lime plaster to do its job with regard to absorbing humidity and absorbing moisture and allowing moisture to pass through it. So that's just something certainly to bear in mind. So when to go hybrid? So possibly in high use rooms, so kitchens or bathrooms, you might want to then consider a pozzolanic lime mix, or maybe a mild NHL2 to add a bit of extra strength and durability while still retaining that flexibility. It's the idea being that if you've got a high traffic area or an area where you've got lots of humidity, yes, you want the absorption of that, but actually you also want the ability to then be able to wipe the surfaces a bit cleaner and a bit more flexibility with regards to how it will stand up to the sort of test of time with the use of that room. Now, what we did cover with some of these hybrid mixes is in our podcast that we did go with Ben Kerslake from Carrington Lime. So he is an absolute lime expert when it comes to having spent 25 years as a plasterer. Go and check out that because he talks about this, but also Douglas Kent, the technical director of the SPAB, and what the works he's been doing for the Old Sun In, which we did a few weeks ago. They both mention earth mixes. Now, I don't have the experience or knowledge of those sort of things. Go and watch those videos because they talk about earth mixes with regard to mixing in with bits of lime, or sometimes not even lime, or clay, to actually create a plaster that has incredible properties to absorb and wick moisture and manage humidity without possibly even any lime involved in it. But I mean, fiercely complicated, very traditional. So then we compare it to then gypsum plaster. Now, gypsum plaster is the pink stuff, comes in a bag. It sets incredibly quickly. So it's great for speed. And that's one of the reasons why it's taken over from lime, because it, with a lime plaster, I mean, I'm just looking at my kitchen through there. I had that when I bought the house, we had a particular damp issue, stripped it all, the gypsum plaster off and replaced it with lime. Now that was 3 coats. That was a scratch coat of traditional haired lime plaster, a float coat, and then a final finish, kind of much harder wearing finish coat. It took about, and this was sort of in sort of early to late spring, about a week and a half to 2 weeks for it to be the right stage where you can get a thumbprint in it, but not pushing in too much and without cracking before you can put the next coat on. So we're talking week and a half to 2 weeks of the first coat, week and a half to 2 weeks of the second coat, and then the third coat. So we're talking about 8 to 9 weeks before I could even consider putting some sort of finish on it, whether it's a lime wash or a vapor permeable paint. Time is money. Whereas with a gypsum plaster, generally within about 2 weeks you can put your first coat of paint on it and then your second coat, and so you're talking much shorter timescales, and that's the reason why gypsum of course is so much more popular with modern buildings, because it's just down to the time element of it. Very smooth finish with gypsum plaster, of course. That may or may not be to your tastes, but of course you've got a coarser finish with a lime plaster, which I love. It's much softer, rounded corners, all very beautiful. But gypsum plaster is much more salt sensitive. Salts really aggravate the chemical bonding of the gypsum, and that's what actually releases often the paint, and that's where you get the paint flaking off, is because of the salt contamination that comes up through the dampness of those dissolved salts in the moisture. Also, it's got very poor moisture tolerance. So whilst gypsum plaster is vapor permeable and does allow moisture to pass through it, it doesn't have the same degree of capillarity as lime, and it isn't quite as hygroscopic either. And so the moisture tolerance is much less with the gypsum plaster. And that's why often, if you've got damp conditions or fluctuating humidity conditions, gypsum plaster performs really poorly. So certainly if you've got at the base of a wall where you've got high ground levels on the other side, or you've possibly got lots of capillary action, what some people call rising damp, gypsum plaster really suffers with that because it can't cope with high levels of moisture to be able to evaporate out. And that's why, often people sort of say, oh, you've got gypsum water, strip it off. Well, it's actually because you've got high levels of moisture coming up through it. Sorry, go on, Stephen. Yeah.
Well, I was just going to interject there because the other thing about gypsum plaster is I've recently come across research that shows that it contains various components, chemicals, minerals within it that are particularly attractive to mold growth. So you mentioned moisture, and a form of moisture is condensation. And if you get condensation and it lingers around long enough, you're going to get mold. And that's particularly the case with gypsum plaster, that you'll more likely get mold. Sorry to interject, but I just thought I'd mention that.
It's a really valid point. I mean, it's not something we're specifically covering in this podcast, but I know we've got a future planned all about mold. But also to say that because of the alkalinity of lime, it's a less habitable environment than gypsum, which isn't quite as alkaline, and therefore mold struggles to grow. That can grow, but struggles to grow on a lime plaster much less readily, I suppose, than it would on a gypsum, because of those chemicals as well. But that's a great segue for future video coming up, where we've got a particular mold expert that we're lining up for the podcast, aren't we, to talk to about this sort of thing. Anyway, I think that pretty much sums up what we were going to talk about internal plasters, with using a traditional air lime versus a natural hydraulic lime, and the benefits and pros and cons of each. I think the best way for me to sort of explain it is essentially, when you're talking about performance, I'm talking about performance of moisture, and then you've got performance of moisture offset against speed of setting, quite frankly. And at the one end of the spectrum, you've got your traditional air lime plaster, and at the other end of the spectrum, you've almost got, let's say, a hard concrete render. Within that sort of segue from this end, which is your traditional lime plaster, best possible performance of moisture, but then a much longer time to set and carbonize. You then come to your NHLs, which are not quite as good moisture performing, but set quicker. You've then got your gypsum plaster, and you've got your gypsum plaster, which is much faster setting, but not such great moisture performance. And then you've got your concrete render, which of course has got very little moisture performance, but actually is incredibly fast setting. So I hope that helps. And again, depending on your situation, depending on whether you need moisture performance or depending on when you need speed, that's where you've got to choose which is the right material for your internal walls. Stephen, over to you. That's inside. Let's talk about renders outside.
Okay, so yes, external renders. Why do we render buildings? Well, usually it's for weathering purposes, and traditionally that's what happens. So I'm over here in the east of the country, and we're not necessarily the wettest part. I think Rich is in a wetter part over in Gloucestershire than I am over here in Hertfordshire, Essex areas. But what we will find is, if you look at a lot of timber frame buildings in particular, they were rendered historically to protect the frame and to protect the building from the elements. Obviously, render isn't the only way of protection, but it was a common and readily available way. Now, when the Georgian period came along, they were all into gentrification of buildings. So they tended to render partly to cover up these dirty, horrible old buildings that they didn't like to see, and partly because they liked the appearance. They wanted to make it look like very fine stone So it was all about pretense, really. So they rendered the building and often scored it lightly to make it look like stone. We called it an ashlar type finish. And, that's what it was about. It was about pretense, making it look different. And that might be on a timber frame. It might be on a brick building and so on and so forth. So you get these various different finishes. So rendering is about, firstly, weathering, and secondly, about appearance. What does render have to deal with? Well, first of all, it has to deal with wind-driven rain, but also freeze-thaw and perhaps movement. If we've got a timber frame behind it, the timber frame is going to move around with temperature changes, etc., etc. Moisture, atmospheric moisture changes are going to affect the timber. So you've got a moving timber frame. If your render is too rigid, then you've got that movement of the frame and the rigidity of the render, and the two don't work well. So then you get cracking. And once you get cracking, you get a more direct route for driven water to get in, for the rain to get in. And once the rain gets in, it's not going to get it out so easily. So the harder that render is, whilst it may, on the face of it, it may protect from rain and driven rain, etc., the harder it is, the more brittle it is, and the more susceptible it is to movement causing it to crack. Once water gets in, it can't get out. Then you've got trapped moisture. Therefore, we've got a problem. And of course, if you add into that freeze thaw, because once water's behind, and if we get into a spring, autumn, winter period where there's a bit of frost, that water will freeze. Frozen water expands. As it expands, it damages the render. It pops it off, or it might jack it out. We call it jacking out, where it pushes it slightly out. Now, as it does that, a little bit of the dust and mortar from the back of that render will fall down, and it won't be able to get back in again. So each time it gets worse and worse and worse, and the cracks just get worse. And eventually you end up with a blown section. So when you tap it, you can hear a hollow ring because it's blown. So why am I talking about all this? I'm saying all this because it's so important that we get the right render in the right situation. If we start from the point of view that our airlime, our natural airlime, is the best thing to use, well, let's come back to that. But let's start by saying it's the most appropriate thing to use because for all the reasons we've heard, it's flexible, it's vapor permeable, and so on and so forth. So if we put it on one of these buildings, it's going to be able to flex. It's not going to crack so easily. Whilst it gets a little bit wet, it'll release it. I often liken it to the difference between a woolen overcoat and a plastic Mac. You wear a woolen overcoat, it gets wet, and if it's really wet, it might come through, but it'll very quickly dry out again. You wear a plastic Mac, and whilst it keeps the rain out, inside it, you're sweating. And if a bit of rain does get in the neck, it's not going to get out again. You're wet. And it's a similar thing with renders. With our pure airlime, that will have the best of everything in many ways. However, we've already said you can't use it outside of the period, let's say May to September. So what happens if you want to do work over the spring, autumn, when there might be frosts? Are you going to leave it for another year? Especially if you've got an exposed building and problems that you can't leave it exposed, or, so there's a question there. But what about those situations where you're very exposed? Because with any building, we've got effectively, if we imagine that a building is simply a cube sitting on the ground, it's got four sides to it. One or two of those elevations are going to have quite good weathering situations, but you might have one that has all the weather being thrown at it. And so therefore, it's going to take a lot of weather beating. Would that airline be best in that situation? Because it could wash out very quickly, it could deteriorate quickly, and no sooner have you put it on, it's come off and you're having to do it again. So in those situations, would an NHL 2 or 3.5 be more appropriate? And the answer is quite possibly, yes, that might be more appropriate. So I think the thing to do is to think about the building and what you're trying to achieve. Think about what's been on there in the past and may or may not have worked. And then think about what you're going to use. And it is quite possible that you'll use a different type of lime for different elevations, simply because of the exposure, or maybe even the substrate. That might affect decisions as well. So these are the sort of things you need to think about. The other thing is the actual aggregate itself. We often talk about sand being the aggregate, but historically, sand wasn't available to everyone. And so we often now realize that they used maybe chalk if that was available, or earth, and so on and so forth. So lots of different things were used. I mean, sand is what we typically use today, but actually chalk as an aggregate makes a much more flexible material. And I in East Anglia have used a chalk mix quite regularly on jobs, and it's worked much better than a sand mix. So, these sort of things need to be considered. And we did actually discuss this with Ben in the podcast with Ben Kerslake of Carrington Lime. So go back and have a look at that, and you'll hear us talk about some of this. Anyway, so those are some of the issues. We need to think about the carbonation, protecting. You'll often hear about people hanging Hessian in front of a lime once it's been applied, and that's to protect it from sun, beating down on it and drying it too quickly, and you have to spray it with like a garden spray hose, keep it wet occasionally. But also the Hessian, if it happens to rain one day, stops it getting too wet. You don't want it getting saturated. So we need to think about all this. The last thing I want to mention is going back to our Victorian Edwardian period and the hybrids we've already mentioned. Now, in the Victorian period, they were keen to use these new materials, and they didn't always get it right. So just because your building has got a hybrid mix, it doesn't mean to say it was the right material. In the majority of terraced Victorian houses, for the pointing, for the mortar bedding, it's not usually a problem. However, there are situations where some of these buildings were rendered with an early form of cement, and that has been a problem. So a prime example of this is Macintosh's building, Hill House, up north of Glasgow, where back in the turn of the 20th century, he built this fantastic house. If you haven't been there, it's well worth going to. But it's a fantastic house. But he rendered it with cement render, and that has failed. And it has failed big time. And it's caused no end of trouble for the building. And that's actually got a temporary surround to protect it from the weathering at the moment. And they're thinking about what to do with it. But there's an example where using the newfangled material, this newfangled cement render, I'm going to use that, said Macintosh, because it's the modern thing to do. No, it was wrong. It failed. So just because they used it doesn't mean to say it was right. So we need to think very carefully about what did they use? Did they get it right? Did they get it wrong? What should we use? Start from using the least harmful, the air lime, and then think about what might be appropriate particularly if it's exposed. So anyway, hopefully that helps with the renders. Sorry, Rich, you were going to ask me something.
Yeah, well, there was just one point I was going to sort of add into that in terms of looking at history in terms of what was used, absolutely vitally important. However, in the last 100 years, with climate change, we have seen from a meteorology perspective that rainfall is becoming more frequent and much heavier. And therefore, that is having an impact upon what we specify for our older buildings now, because what was used 100 years ago actually might not be quite as appropriate now. For example, using in a very exposed area where it's getting a lot of rainfall to it, and if that rain isn't being carried away with the good rainfall goods and all the rest of it, you might find with a particular type of render, if it's lime-based, that it will never dry out between bouts of rainfall. And therefore, there are some situations, very, very niche situations that I've heard of, where actually a cement render for a particular facade or a particular exposed area is appropriate because it's the least bad for it. Yes, it reduces the vapor permeability through it, but you're not going to get the render being wetted and staying wet because it won't ever dry out. So, yeah, like you say, all comes down to context and knowing, but there are changes in weather patterns that have made a difference.
Yeah, I think although it takes us slightly away from talking about limes, which is what this podcast is about, if you're dealing with a very exposed location, I have on many occasions said to people, think about a cladding, actually putting a cladding on, whether it be slate or tile or something that is going to be protecting it from the weather. Obviously, you'd need to leave a bit of an air gap behind it, perhaps, to allow for the permeability of the structure behind, but put a cladding over it to protect that building in extreme circumstances.
True. And that would be much better, of course, than a cement render, of course, because then you've still got the permeability to the air gap behind it. So, yeah, a very fair point.
We're finishing this episode here, but listen out for the next one where we'll deal with exposed locations on buildings and floors. Thank you very much. See you again soon.